Here we're going to discuss some basic probability concepts. Things like mutually exclusive events, collectively exhaustive events, and independence. But independence will be a part of second video. So there are 5 questions. Pause and try. Okay? So here's the first question. There are 2 events C and D. If probability of C is 65%, what's probability of D? And put it on pause. Think about it. Okay, so here we go. C is 65%. What is D? The problem is we do not know anything about D or the whole system. Are there more events like E, F, and G? Do they overlap? Do not overlap? Are they disjoint? So conclusion is we just do not know. Need more information. The 2 events A and B, they're mutually exclusive. If A is 35%, what is B? And here we go, put it on pause, think about it. 2 events A and B, mutually exclusive. That means nothing in common. So that's what we're looking at here. A and B. A is 35%, what will B be? Now you might tend to say 65%. But the problem is, are there C's? Are there D's? Right? So think of, I get 35% people get an A in the class. How many get a B? Well, 65% or less, correct? Because you do not know, did I give C and D and all that, right? So that's done with it. So it is 65% or less. Next question. I defined 2 events from a class in regards to computers, W, Windows, and Mac. They're collectively exhaustive. If the probability of W is 65%, what's the probability of M? Okay. So what we have here is this, that they're collectively exhaustive. That means everybody has a computer. These 2 events collectively exhaust the class in terms of computers. Everybody has it. If 65% of Windows computers, how many will have Mac? Okay, and you might be thinking of, well, 35, right? Well, the correct answer is not that. Because we do not know it's this situation or that situation. 65 have Windows, and how many will have Mac computers? Well, the problem is, there could be some of these people who may have Mac computers, right? But they may have Windows computer, they might overlap. So the point is, in a class of 100, there might be more than 100 computers. People have more computers than one. If they don't, then it will be there. There's nothing in common, disjoint events, 65 and 35. It does not say we are here or we are there, which means we can only say it is 35 or more. Next question. The 2 events W and M, let's say Windows and Mac, they're collectively exhaustive but not mutually exclusive. If the probability of W is 65%, what's the probability of M? Okay, here is your clock. Okay. So, collectively exhaustive, that means these 2 collectively exhaust the whole class. That means everyone has a computer. But they're not mutually exclusive. That means there's some common events. That means somebody has 2 computers. At least someone has 2 computers. Otherwise, they will be mutually exclusive. So that's what we're looking at here. This one and that one, and some have more than 2 computers. In that case, the correct answer simply will be 35% or more. I mean, more than 35%. Because someone has 2 computers for sure. Okay, the last question. The 2 events A and B, they're collectively exhaustive and mutually exclusive. If A is 65%, what is B? That's not B, that's a B. Okay. And collectively exhaustive, that basically means that they cover the whole class. And that means there's nothing in common between these 2. Now, this will be a situation, suppose I give A's and B's only. 65% got an A, how many got a B? There's no C, there's no D, there's no E, right? So that will be this situation. 65 got an A, 35 got a B. In the next video, we're going to talk about independence. So for now, we are done.